Hello everyone. I'm going to go through the practice test I've given you for our stats topic. Let's make a start. The non-calculator section, question 1. A man is standing on the edge of a pond skipping rocks along the water. He counts how many times the stone bounces before it sinks and records the results as listed below. Question A. Complete the frequency table for the results and display the scores in a dot frequency diagram. All right, let's do this. Score of 0. What's the frequency of that? How many times does that come up? I'm going to scan across and see it doesn't actually come up at all. So it has a frequency of 0. How many times does a score of 1 come up? Well, let's cross it off as we go so we don't make any mistakes. And we're going to get, there's 1, 2, 3, 4, 5. What about a score of 2? 1, 2, 3, 4, 5, 6, 7. And what about a score of 3? 1, 2, 3, 4, 5. There's one score of 4, and there's one score of 5, and there are 0 scores of 6. Let's translate that now into a dot frequency diagram. I'm going to start by setting up my axes. So let's first write my values in. You know what? I'm going to make it a bit more spread out, and we're going to have it like this. 0, 1, 2, 3, 4, 5. And then my frequency up the top. 1, 2, 3, 4, 5, 6, 7. And I'm going to label these axes as well. So this is going to be the frequency, and this down here is going to be the number of bounces. Great. Now I need to translate these numbers from my table across to my dot frequency diagram. So let's do it like this. A score of 0 happens 0 times, so I don't need to worry about that. A score of 1 happens 5 times, so 1, 2, 3, 4, 5. I have 7 2s. I have 5 3s. I have 1 4, and I have 1 5. Excellent. Question B. Describe the symmetry of the distribution. Well, if we look at it, it's not symmetrical because it kind of trails off to the right a bit here and is extended in that direction. So my answer is going to be that it is skewed to the right. I could also call that positively skewed. They mean the same thing, and both would be correct. So let's look at the marks for this question. 2 marks for each part. So I'm going to get 1 mark for filling out this table correctly, 1 mark for doing my dot frequency diagram correctly, 1 mark for noticing that it is skewed, and another mark for correctly stating which direction it is skewed in. Question 2. 3 gymnasts each perform in professional competitions in various cities. They meet up afterwards and compare their scores. Ash received a score of 13, Bree received 8.5, and Chrissy received 21. What main pieces of information are missing that would allow us to accurately compare the gymnasts' scores? Well, if you guys remember, we've gone through this in class. Those scores at the moment don't really mean anything to us now because we're missing 2 main things. The first one is pretty obvious, and that is that we are missing what the score is out of. So if it's 13 out of 15, that's quite impressive. If it's 13 out of 50, then not so much. So I need to know what is the score out of, because if they're all doing different competitions, then they might not all be out of the same thing. And the second thing that I need to know is, well, one set of judges might have judged harder than another. So to know how well they did, I need to know how everyone else in the competition did, and I can sum that up in 2 numbers. and those would be the mean and the standard deviation. So this tells me how everyone else did, and this tells me how the particular competitor did. Okay, question 3. For this question, let's just work out this notation here. For this question, my distribution x is normally distributed with a mean of 35 and a standard deviation of 2. To help me with this, I'm going to start by just drawing that distribution on the side over here. So let's draw our bell curve. It's got in the middle here a mean of 35. And because the standard deviation is 2, I'm going to jump up in jumps of that standard deviation. So this will be 37, this will be 39, this will be 33, 31, and I'll add that third standard deviation on as well. 29 over here, and 41 up there. Now remember, because people often make this mistake, the graph does extend past that third standard deviation. Okay, let's look at these questions. Question A, what's the probability that x is greater than 35? Well, that's an easy one because 35 is the mean, and we know that half of the scores lie above and half lie below the mean. So the probability would just be 50% or 0.5, because remember we write our our probabilities not as percentages but decimals. Question B, what is the probability that x lies between 35 and 37? So I'm just going to get up a different color here so that we can show you that area that we're talking about. It's always good to shade it in between 35 and 37. Well, I know that from 33 to 37 is 68% of the scores, and because it's symmetrical, 35 to 37 will have half of that. So the answer will be 68 divided by 2, which gives me 34%, and I'm going to write that as a decimal for the probability, so probability equals 0.34. Question C, what's the probability that x lies between 37 and 39? So now I'm going to show you that with a red pen between 37 and 39. We'll shade that in. Okay, well, let's think about this. There's a few different ways we could go about this. The way I'm going to do it is like this. I'm going to say that from 31 to 39, we know that there's 95% of the scores. But 68 of that 95 lie between 33 and 37. So if I shade this bit in red as well, what would be the total of this red bit? The total of that red plus this red, so all the red on that graph, will equal 95 minus 68, which gives me 27%. But the red on the right side is the only one we're interested in, so I need to do that 27% divided by 2, which gives me 13.5. So my answer is P equals 0.135. Excellent. Question D. Which percentile would a score of 33 be in? So for this, we just need to remember what the definition of a percentile is. A percentile is, or a quantile, is defined by what percentage of scores lie below that number. So in this case, we need to work out what percentage of scores lie below 33. The way I'm going to do that is by thinking about, first of all, what percentage of scores lie below 35. Below 35, we have 50%, and from 35 to 33, we worked out over here, we have 34%. So 50 minus 34 is going to give me 50 minus 34 gives me 16%. So 33, a score of 33 lies above 16% of the scores. Therefore, the score of 33 would be in the 16th percentile. Question 4. Consider this data set. What is the interquartile range? Okay, so for that I need to know what my quartiles are, which means I need how many scores there are and my median, and let's split this up. So let's count first of all. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers altogether, which means that my median is going to be over here with 4 on either side of that line. My median is going to be between 107 and 109, so it will be 108. My first quartile will be then over here with 2 scores above it and 2 scores below it. And my third quartile will be over here, again with 2 scores above it and 2 scores below it. The interquartile range is the third quartile minus the first one, which in this case, my third quartile is 109. My first is between 104 and 106, so that's 105. So my interquartile range is 4. Question B. Would a score of 114 be considered an outlier? Justify your answer. Well, let's remember an outlier, it's considered an outlier if it lies more than 1.5 times the interquartile range above the third quartile, or 1.5 times below the first, 1.5 times the interquartile range below the first quartile. So if we're looking at the number 114, before we can work out whether it's an outlier, we need to know what is 1.5 times the interquartile range. So if the interquartile range is 4, what's 1.5 times 4? And that's going to give me half of 4 is 2, so 4 times 1.5 is 4 plus 2, which gives me 6. And my third quartile was 109, so 109 plus 6 equals 115. Anything above 115 is considered an outlier. So 114 is not an outlier. Okay, the score 108 is then added to the data set. How would this affect the median? So when it says how would this affect, that means would it make it higher, lower, or keep it the same? In this case, we can look up here and notice that our median is between 107 and 109. Our median is 108, so adding the score 108 would not change that at all. So the median would not change anything. The median would not change. D, the standard deviation. Well, let's think about this. If I insert another data point that is right in the middle of my data set, it's going to make my data set less spread out, and it's going to have more data in the middle. So it will make the standard deviation lower, because standard deviation is a measure of spread, and if there's more data in the center, then it's less spread out. And it will also have no effect on the range, because the range is just the maximum minus the minimum, and seeing as 108 isn't either of those, it won't change it at all. Okay, that is the non-calculator section. I'll make a separate video for the calculator section. Let me know if you have any questions.